Ladies and gentlemen, our next guest is a physicist, instructor, and professor at the University of U. He was kind enough to come on my podcast. Super nice guy. Has a lot of interesting things to teach us, and I'm just gonna pick his brain.
All
Adam,
right.
how you doing?
Today's been not as planned, but it's all worked out, so I'm good.
Good. Well, you know what? Days like this, you just say I made it through. That's 100% success rate.
Wasn't as you planned either. Even better.
Yeah, that's true. But those are fun days too, right?
That's correct.
So you're a college professor.
Yes, yeah, I teach at the University of Utah in the Department of Physics and Astronomy.
Nice, nice. And you said you also do experiments with physics.
Yeah, I was actually hired. My official title is a lecture demonstration specialist.
What does that do?
Yeah, that's common. People go, what the heck's that mean? Picture yourself in a lecture, and the instructor's talking, they write on the board, they show PowerPoint. That's normal. But if they want to use equipment to show a demonstration of how something works or to help visualize or help explain something that maybe you can't get just by talking or drawing pictures, that's where I come in.
Like the Higgs boson? No, I'm just kidding.
Yeah,
That's too big.
I don't have that one yet.
You don't have that one yet? It's only one, right? In Switzerland?
It's Switzerland.
That's in Switzerland, right? Geneva?
Oh,
The
where,
Higgs
where
boson
they,
collider?
the
Yeah,
collider where
yeah,
they
the
discovered
collider.
it. But yeah,
Yeah,
there's
yeah.
in theory more than one
Cool.
Higgs bosons. But so yeah, I'm in demonstration. So the boring from block on an incline, or set up an electrical circuit so you can compare light bulbs in series versus parallel, or a Tesla coil with million-volt sparks.
That's what I was thinking.
It's more fun when they are zesty. But
Yeah, yeah. Do you think Tesla's underrated as far as like his genius and all the things that he created versus like
definitely.
definitely, right?
Definitely. He definitely wasn't a businessman, and that was kind of his financial down failure. But no, he was a genius in figuring out all that alternating current stuff that we still benefit from today. So
Didn't he also invent like wavelengths or not like radio in a sense, like modern radio?
he was the first Wi-Fi, without wires.
That's
Because a
crazy.
Tesla coil will emit the sparks, and it emits energy in the form of electromagnetic radiation, which is just a wave. Light is a wave.
Okay.
Radio waves are on the electromagnetic spectrum. X-rays, microwaves, radio waves, TV waves, all that are electromagnetic spectrum. And yeah, they transmit, and it carries energy with it, and it can be transported into a light bulb and lighted up wirelessly across the room or town. And that was one of his goals.
And you did that over 100 years ago.
Yep.
That's crazy. Where do you think this guy got the information? There's a lot of theories. I mean, of course, he's a genius. He's like a super genius. Um, Aliens, downloads. He had dreams about this.
Yeah, it's not all clear, but it seems like, visions, dreams, it came to him.
It
He'd
came
draw pictures, and he got the idea. I mean, based on his studies, so that he had a base to build on. But yeah, and then he tried it out. Clearly, though, from the readings, he had something in mind. It wasn't just like, I'm not quite sure.
he had a working memory, right? Like he would do it in his mind.
I don't know about that. He may have. I don't know.
Okay.
I can't
Yeah.
speak to that. That's what I'm getting at. But he clearly thought it was going to work. He just needed to put it together and do it. It wasn't like, oh well, let's put it together and see if it works. He believed it was going to work. And
So yeah, so
Well,
he saw it in his mind's eye.
did.
Nice. That's awesome. That's awesome. He saw it in his mind's eye. Okay. Anything interesting about modern physics that you're reading up on, you're studying up on, or that you've heard recently?
Recently,
I mean, past 10, 15 years.
I don't know. The one I think is amazing is the detecting gravitational waves.
What?
Uh,
You want to elaborate on that?
you throw a rock in a pond and you get ripples.
Right.
The waves go out radially outward from the center, and these gravitational waves are essentially waves like in the fabric of space-time, which is another confusing topic. But I don't know. Picture the universe just made up of this space-time fabric, kind of like water.
Okay.
And in order to make a big enough wave that we could detect, which is extremely, extremely, extremely tiny, it was two black holes, and they merged, and they were looking for this. And when they came together, it was like they orbited around each other, and they collided into each other and produced such a massive wave, like throwing a big boulder in the pond. And these waves went out through space-time really, 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 really far away. And by the time they got to the Earth, we were able to detect just a little bloop of it when the ripple got to us.
This is in a different galaxy that this happened.
Thousands over, yeah.
Okay. So let me just get this straight. Two black holes collided together and caused a big ripple. Wouldn't that cause like a white dwarf or something like that?
Different stages of stars when they die. If they're massive enough, they become black holes.
Okay.
Now, two of those got close to each other, and they have a lot of mass, so they attract each other, and over time, these two got together, and then they collided. So, picture like our sun colliding with another star. It was like that, but on a much bigger, grander scale.
Dude, that's crazy.
And it created shock waves in a sense.
How do you detect that?
That's what I think was amazing. They used an interferometer. More words.
More words, big words.
But bottom line is they detected a change. It caused a change on the Earth, like on the order of the diameter of a proton or something like that. Really, really small.
Really, really.
That's the change that it made by the time it got to Earth.
Would humans even feel it?
Oh no.
Not at all.
No. They were even having a hard time detecting it with these fancy modern equipment because it was that small of a change.
Okay.
This interferometer they built was able to detect it. But the really amazing part is all the statistical analysis and data they had to do to get rid of all the noise.
Yeah.
Because it's like, again, throw the rock in the water. Here comes the ripple. You're 10 miles away.
Yeah.
You think the ripple's gone. It's like not doing anything, but a little bit gets there. And how do you know, though, if the wind's blowing or a boat goes by? How do you get rid of all that to detect this very minute change? And that's what this interferometer did, and that was just amazing. The reason I thought of this, I can get back to the interferometer.
Yeah.
Is I guess recently they've discovered more of these. Like I don't know,
more of it. Okay.
10 or 12 other ones I read. Other mergers, and they were able to detect them too. And so they're getting better at it.
Good. That's cool.
But it's cool. Interferometer. Let's see. In essence, it's wave interference. Waves go up and down. And if you got two waves going together and they're in sync, like in phase, they say, if they're both going up and they're both going down, they can add to each other. It's like sound. If you made the same sound I did, it'd be louder.
Mm-hmm.
If it was light, it'd get brighter. If they were out of phase, out of sync, one was going up while the other was going down. Basically, one was trying to vibrate in one direction while the other's trying to vibrate in the opposite direction. They would cancel each other out, and sound would get quieter, the light would get dimmer. And these bright and dark spots, loud and quiet spots, create interference. Let's relate. Some people might understand with speakers. If you're in a room, they like to place their speakers appropriately. So that it sounds better.
Acoustics.
If you sit right here, it sounds awesome.
Yeah.
That's because the waves are constructively adding together and
they
making
hit
it
your
louder
ears.
right there.
Okay.
But
Okay.
I don't know. You move 3 feet this way, it might not sound as good because they're destructively out of phase, one up, one down over there.
Very true.
Well, that's a pattern if you kind of mark it out. Well, here's a loud spot. Here's a quiet spot. Here's a loud spot. Here's a quiet spot. That's what they could do with these gravitational waves.
That's awesome.
They send one down one direction, and this interferometer they did, it was underground. And they're like, I don't know, but kilometers long, each leg. It goes one way, and another one's going perpendicular to that. They bounce off these mirrors. They come back. And when they come back, if one of them got jiggled, it could cause them to be out of phase when they're back, differently than they were before the jiggle.
Uh-huh.
And they notice that little shift. It's a really sensitive way of detecting.
So were they like shooting in the dark in a sense to see where it bounces back from, where it doesn't bounce back from? Because they don't know, right?
Well, they were shooting lasers down and seeing the interference pattern.
Mm-hmm.
They're watching it. And if a gravitational wave came by that jiggled one of these legs of the interferometer, they would see a shift in the interference pattern. I'm simplifying.
Okay.
We detect earthquakes like this. That's how you can get, something rattles up in Yellowstone.
San Andreas?
Yeah, it sends a wave down here and makes a little shift, and somebody's interferometer down here. It's one way to detect them, and they can tell how strong that earthquake was.
Okay, got it. Let's go into some theories.
'Kay.
Do you think time travel is possible? Or is it theoretically it is possible, right?
Yeah, I guess so. Theoretically. Do I think it's possible? Mostly no.
Mostly no. No Back to the Future? Oh, man.
Yeah, no. I don't.
What are your thoughts on it? It's not possible because the future hasn't happened yet? Or the past is already, can't go back to the past?
Well, more like because we're for us, in the state we're in,
The present moment.
time just moves forward sequentially. It's like it flows past us, even though technically we're the one flowing through time.
We're the one flowing. I mean, time is just made up, right?
Here on Earth, the way we're living our lifestyle, I don't believe it's possible. There might be other states that we can't exist in, or maybe something else exists in that we don't know and can detect, in which case, like where time doesn't exist, or
Yeah.
if like time doesn't exist, then what's the point of time? Then, of course, you can consider that a form of time travel, because past, present, future are all before you. So it's like you could go in the past, but there's not technically a past because it's just all there. So in that sense, maybe.
Maybe. I mean, theoretically. Yeah. Okay. If you go to the speed of light, according to Einstein, you can travel.
Oh yeah, that thing.
Yeah, that
yeah,
thing.
the current theory of relativity, special relativity, is nothing can go the speed of light and transmit energy or carry information. It's like the ultimate limit. But again, it could just be in our current state. Maybe we've never discovered anything that can yet. And then if we do, we'll change it. That's one thing I'd like to emphasize. A lot of people.
Yeah, please emphasize
You
on
say
that.
theories, and the non-scientists think, oh, it's just a theory. They don't really believe it or have enough proof. In science, actually, theory is like one of the highest things. Like it's like law. We have facts. We have evidence. We have laws that we create, like Newton's laws. And then there's theories. It's like all this together that everything we've looked at so far, or discovered, or experiments point to this, and this is the way it works. And these laws predict what will happen. You know, if I push on you because with this force, when you have a certain mass, you'll accelerate this fast. If you my mass, it'll be different, and we can predict all these, and all that together are theories, and they're solid and sound based on what we currently know.
But you can't prove them. It's a theory.
Yeah, that's the point. That's what I'm trying to make. Theories have been proven over and over and over again.
Okay.
As soon as somebody disproves one or something in there, we have to go revisit it. And good scientists should be open to do that. But the non-scientists think, oh, like you just said, well, theory, oh, it's not proven, it's not real. In science, theories are like the highest, oh, yeah, that's the way it is. So this special theory of relativity, for example.
It's special.
It's to distinguish it from general relativity.
Oh, okay.
It's Einstein thing.
The Einstein thing.
But theories, they're like solid and not unchanging. I don't want to say that, but they're what we go on in science.
Okay.
Until we know otherwise or have something to contradict it. And if something does come along, then we'll revisit it, reevaluate it, and change it. So the special theory of relativity currently says nothing can go faster than the speed of light and transmit energy
that we know
information. Right. That's my point.
Okay, good.
So we've proven this. Every experiment that has been done has shown this to be true up till now.
Okay. So yeah, but technology is advancing really, really quickly.
Exactly.
So in like 200 years, something.
Who knows?
Yeah, who knows?
Right. Maybe there's some state of matter we haven't discovered yet that can.
Yeah. Yeah. Speaking of matter, what about antimatter? Can you tell us a little more about that? Do you know about it?
Oh yeah, I know about it. I'm not an expert.
No, I don't need like expert. I don't need you to draw me a diagram, but just touch on it a little bit.
Oh, if anybody wants to get into this, yeah, it's a whole big world of quantum particles, subatomic particles. And there's just so many different types and styles and the way they interact and whether they have spin or mass or charge and the intermediary or particles that go between them. And I get to this because everything we deal with in our normal world, you, me, what the table's made up of, what we're made up of, is matter. But it's because, for example, a proton, you've heard of protons, they're in the nucleus of an atom, for those who can't remember. The center part of an atom. There's one of the particles is a proton, and it has a charge, an electrical charge that's positive.
Positive.
Well, there's something antimatter to that that's like an antiproton. And it's not like, it's hard to describe. You can say it has the opposite charge of that. Well, that's an electron. That still matter. But there are antiparticles that have some characteristic that's the opposite of our matter, so we call it antimatter.
Yeah.
We don't hardly ever interact or deal with it. They if they come into existence, they almost instantaneously recombine or interact to go back away.
Okay.
The only reason we know about them are an example like a photon, which is a packet of energy of light, so to speak. It could spontaneously, what's the right word?
Evaporate.
decompose or something, and
Decompose.
turn into a matter particle and an antimatter particle. But then they'll immediately refine another one or each other and recombine and turn back into light, ordinary matter. So the antimatter never sticks around
It never sticks around, or it goes somewhere that we
in
don't
our
know.
world.
In our world. Oh, okay. Do you buy into the multiverse theory?
Nobody can technically rule it out yet. So who knows?
Yeah. How would you be able to rule it out?
Well, they try to do tests.
Oh.
There's another thing. Scientists, in order to call it science, and this is where a lot of people get into arguments, is,
Mhm.
oh, well, you can't prove that, blah, blah, blah. And a lot of times scientists have no claim on it. If you can't potentially prove something wrong, it shouldn't be called science. So there's some questions like, gee, now I can't think of any.
Oh man.
Brain lapse.
Okay.
They'll come to me. I can think of hundreds.
Consciousness movie matter.
Well, there you go.
The
Yeah,
Jedi's.
we currently have no way to test that and prove that it doesn't exist. or
What
something.
about the double split experiment with quantum mechanics, where like if you observe it, it goes a certain way. If you don't observe it, something
Well,
else
see, now
happens.
that we could prove because we
Yeah.
can go observe it and see the results.
Yeah.
But until we observe it, we don't actually know. So we assume. And so there's that borderline between what you're going to actually call science and not. Oh, I know. The historical example is evolution. And how we taught, there's the science way that evolution came into being and the
Mhm.
religious way. And there was a conflict.
Mm-hmm.
And the true conflict was only the religious way can't be proven by methods of science. So they basically said, well, we don't want to call it science.
It's belief, isn't
And
it?
so they said, but you have to teach this as another alternative to this. And they weren't against teaching it, but not in science classes, because that's not what science is, because you can't potentially prove it wrong. These methods we've been able to prove, and there's evidence to this. So that's what we know as scientists, that there could be truth to that. And good scientists shouldn't deny it, but they just didn't want it to be called science.
They didn't want it to be called science.
Because if you can't prove it, potentially prove it wrong by an experiment, then it's not science.
Okay.
So, our five senses, sight, sound, touch, science can get some evidence and prove things with that. But, gut,
Now there's proof on that though.
spirit.
There's
whatnot.
proof on.
We're getting closer and closer.
Yeah, we're getting closer.
But
and
you
closer.
see how the line gets
It
blurred.
gets blurred. But that's good that we're getting closer and closer. Because I mean, I'm really into that stuff. Tell you the truth, like gut feelings, intuition. There's this one guy named Dean Radin. I don't know if you ever heard of him. He's a scientist.
I haven't.
He's in San Fran where they do studies where they put stuff on people's skins and they are able to predict things 10 seconds before they actually happen.
Cool.
Yeah. So, I mean, we're getting closer and closer. I mean, how accurate is it? It's actually pretty accurate. But at 10 seconds, that's like the maximum.
So there you go. See, before it seemed like magic. How can you get that?
yeah, but there's
I don't know. I don't know about that. I haven't heard about it, but maybe it's something with the electric field that's produced or the temperature changes. Well, like light detector tests.
yeah.
It's sensing electrical currents between you or a rise in
Yeah.
temperature, things like that. And until we understood that, how could you know someone was lying? It's like magic.
Yeah, but the thing is, that, even it's not that accurate lie detector test because everyone thinks differently. That's why it's not allowed in courtrooms because it's only like 70% accurate.
Right.
Yeah. So yeah, but I mean,
It was just
but
an example.
but then again, if you get an fMRI put on someone's brain and you ask them a question, this is a lot more accurate.
And for those, that's functional MRI, magnetic resonance imaging.
Yeah, that's a lot. I mean, but that's like I don't know, probably like 50 times more expensive.
Well, it's definitely showing what's happening,
mm-hmm.
but making the causal connection that what we're seeing is a result of what we're assuming caused it.
Yeah,
That's harder to connect
Yeah.
100% of the time.
we're digressing here, but then again, sociopaths they believe their own lies. So is it really a lie to them? Nope, it's their truth.
There's truth to that.
Their truth. Ooh, I like the way you came back at me. Okay. So do you think anti-gravity is possible?
I don't know about that one.
Okay.
Anti-gravity. Let's see. Maybe I can give you a little more. Can you define anti-gravity?
The
What is-
opposite of gravity, like you push something down and it goes up. Like where you could build.
Oh, so instead of typical matter,
Yeah.
all matter attracts other matter because of the gravitational attraction due to
Yeah.
its mass or inertia or whatever you want to call it. Is there something that innately repels something else because of its
Yeah.
existence?
And they use that for, I mean, they would use it for spaceships. There's like patents on it, but I mean, I don't know how operational it is.
I can't deny it doesn't
Like a hover.
exist, but I don't know about any,
Okay, okay.
and I haven't. It doesn't seem in the near future
In the near
to
future,
figure it out. Yeah,
W-
it would be some new exotic particle. Maybe some antimatter does it that way because it always seems a little opposite of what we expect. But
okay, cool. I thought I just picked your brain on that. So you do astrology and physics. Where do you see
astronomy.
astronomy? I'm sorry, not astrology. Astronomy. Yeah, yeah, it's different.
I like astrology.
Yeah,
they
but
are- just to clarify.
not that big on that. As far as physics goes, where do you think that's headed towards? Like, what are people concentrating their research on? And what's going on? Like, what's like current like trends that people are trying to prove?
Be honest, I don't know if I have a good answer to that because I'm teaching the non-modern physics stuff
What's not
to,
okay.
to students. Forces, motion, electricity, magnetism, optics,
Okay.
all the stuff we have evidence and seem to understand. But yeah, then you get into space-time and relativity and quantum mechanics that we're still developing. However, that's one reason I got into physics was this open-endedness. You don't like get into a wall and you've just discovered everything that's possible. It keeps going. But you're like, so what are people looking for?
More and more.
Exoplanets is a big one.
What's exoplanets? Like planets that we can habitate.
Um, planets around stars. Our solar system, we got our planets. We're a planet going around our sun. In other solar systems, finding planets that are going around those stars. And there's different methods of doing it, and they've gotten a lot better. But there used to be only like one or two ways to discover things. Those detect them, and they've come up with more. And so there's been a big rise on number of exoplanets,
Mm-hmm.
basically planets exterior to us, that we've been able to discover. Likewise, black holes. It's easier. We've discovered more of them.
I watched a
We can
documentary on
detect
that.
them
Yeah, we can detect them
with
now.
gravitational waves.
What happens when you go into one? I mean, nobody knows. Huh?
You've heard. Let's hear what you've heard.
I have read books on them. I watched a documentary the other day, actually the same day I talked to you last week. And because you mentioned black holes, I haven't really heard. I heard it can stretch you into pieces and destroy you because it just sucks in matter.
Called spaghettiification. It like stretches you like into a long
Yeah,
spaghetti noodle.
yeah. But the thing is, no one that we know has ever been inside of one. I mean, I heard it's like a gateway to maybe a different, I don't know, dimension, planet. Maybe it's a wormhole.
So yeah, see, there's all these
There's
all
all
these
these theories.
ideas, and that would be a non-science theory.
That's a non-science theory.
In that, because yeah, this is what we think might happen. They're like hypotheses, predictions
But if you can't
based
prove
on current sound theory and the mathematics behind black holes.
it, mm-hmm.
This is what seems like should happen, but we have no evidence yet. Thus, it's still conjecture.
So what have you heard?
Well, those things.
Oh, those
yeah,
things,
so you're
okay.
right with that.
Okay.
A black hole would form again a sun. They're different sizes, and if they die and collapse on themselves, they explode. And if that stuff comes back because there's enough matter, gravitational attraction, it'll pull it back and collapse, and the pressure will make it really, really, really dense. And in the white dwarfs, neutron stars, black holes. Black holes are the king, so to speak. They were like the biggest ones. They now have the most mass. They're so massive that light can't escape.
Yeah, that's what I've heard. They're like super dark.
That's like we can shoot a rocket to the moon, to the space.
Mhm.
Well, there's something else to debate, but I believe it. We're not getting
You
there.
do?
Oh yeah.
I mean, yeah.
I'm saying that, but people are listening to this. Some people might not, and I'm like,
Yes.
But anyway, point is, we can make a rocket that can escape our Earth's gravitational gravity. Black hole, if light went in, it couldn't make it out. It can't go faster. Light isn't going fast enough and to have enough energy to escape a black hole because it has such a gravitational attraction, which is why if you got too close to it, it would stretch you out. Because
Okay.
here we don't notice. The gravity at our feet is about the same as gravity at our head.
Yeah, it is.
So the pull on us is fairly uniform. Gravity is so strong there that the change in gravity over our 6 foot length would be drastic enough that it'd be so large on our feet if they were closest to it, it would start pulling them harder than our head and stretch us apart. Yeah.
Okay, got it. Next question. You mentioned the moon. Do you believe in aliens, extraterrestrial life? Do you believe anything like that's possible? Ooh, non-silence.
Well, it's kind of like I'm religious,
Yeah.
and I want to say science to me is a one way of getting at truth. That's why I love it.
Okay.
I like getting at truth, like you like learning.
I like learning.
Religion for me is another way of getting at truth, and so I don't have as big a conflict between the two. And I'm actually a little sad for those that only choose one or the other and dismiss the other one outright, because it's like, well, you could read a book to learn something, you can watch a movie, you can listen to this person, and there's different ways to get at truth. And I'm all for any method that's valid. And so this is one where there's conflicting things between my religious side and my science side.
About aliens?
Yep.
Really?
Yeah. So do I believe there's other people that exist out there? Yeah. Because, well,
Nice.
for one, I believe in God.
Yeah, I believe in God too.
So in that sense, that would be an alien, because an alien's technically anybody that doesn't live on Earth, right?
Yeah. Yeah.
So that's why I was hesitating. Do I believe there's other populated worlds like that? Yes, but that's my religious. I don't have any
Yeah.
science proof for that.
There's no science behind it. Okay.
So
I mean,
for science side, no. For religious side, I do.
okay. But there's more and more videos, like even the government release of like TikToks and things that defy modern science, like the way they travel, like those. You know what I'm talking about? Like those little TikTok, like airplanes. They look like a TikTok.
I don't know these.
No, the U.S. government even acknowledged it. They're like, we don't know what it is. Like they've seen like dozens of them.
So
And
it's
they've-
technically a UFO, huh?
No, it's 100% a UFO. Yeah.
Because it's unidentified.
It's unidentified, right. But they don't know what it is, and it just defies modern physics, where it could just go like 200-300 miles straight, and it just turns right away, like at a 90-degree, which like planes can't do that now.
So there we go. It's something that, when we don't fully understand it, it seems we either outright dismiss it, call it magic, or say, no, you're full of baloney, right?
Or we could just investigate it more.
Well, yeah, then we get more knowledge, and
Yeah.
there's many things, and eventually it might be part of science. But right now, that's something that seems weird to us.
Oh yeah.
And I'm open.
Yeah, I'm open to it.
Scientists
Thank
should
you.
be open too, because if we're not, we'll never learn any new science.
Yeah, but stay grounded. Don't.
Well, yeah,
Yeah.
you can't. Well, you do tests and experiments, and if somebody else can't reproduce it, then we can't rely on it. We can't use it to help us if only one person's the only one that ever claims to have understood it or seen it or experienced
Yeah.
it. So, and it takes a long time for these theories to build up, and we use them. Like, force equals mass times acceleration, since I used it before. That's Newton's second law. It works. It seems to work. And until somebody proves that it doesn't, we're going to keep using it.
Okay. Yeah, that makes sense. Yeah, that makes sense. That definitely does make sense. It works on this planet, but on another planet, if they have different elements, they might do things differently.
Everywhere we've gone so far,
It works.
it works.
Okay, got it.
So, yeah, on satellites and on the moon, and
Okay.
sending satellites to Mars and on Mars, it's all worked. So, more evidence.
Got it.
But,
Now,
yeah.
I feel like one thing that science is having a hard time with is consciousness. 'Cause-
Well, yeah.
Yeah. He said, well, yeah. Because they try to do different studies, and everyone's different. Everyone's brain and mind works differently. And like they try to do the same replicate the same studies, and it doesn't come out accurately. What are your thoughts on that? Because there's even studies now with physics.
Was that a pun? My thoughts, consciousness?
No pun intended.
Personally, non-scientist me, I think consciousness, thoughts, inspiration, revelation,
Yeah. Mystical experiences.
spirit
Mm.
is like a higher form of light. I don't know. We see light. You got these lamps there shining on us. They're like physical light. Maybe it's a more coarse form, like
Like higher selves of ourselves.
condensed water or whatever. I don't know. Different forms of, you can have different forms of water.
You can.
well, vapor, ice, liquid,
Yeah.
just different forms. This is my non-science side. I'll claim that for those.
No, no, that's cool.
I think it's like a higher form of more refined matter that we just haven't discovered yet. I feel consciousness lies in there somewhere. So maybe someday science can understand it, but you know how we keep finding smaller and smaller particles, or you've heard of matter and the
Dark
Higgs
matter.
boson. And
Higgs-
what are
yeah,
these
yeah.
things? We didn't know about these
Yeah.
100 years ago, and here we are. I think consciousness is something like that.
Yep.
I think that it's real,
Yeah, it's 100% real that we're here.
and somehow we can interact with it. Well, we do interact with it,
Yeah.
but that we're not there yet.
We're not there yet.
And so it seems unreal. And in that regard, typical scientists want to say, well, don't call it science because we can't potentially prove these claims wrong yet.
But it's there.
Right. So that's why, okay, outside of science camp, let's use it and work with it and go with it. But in the realm of science, there's a lot to do with the conscious that can't be proven
Yeah.
for a scientist.
Yeah. That's why the NIH also.
And again, that's why people get in arguments. It's not because they necessarily disagree that consciousness doesn't exist. Just from a scientific perspective, they
Mhm.
can't prove it.
Well,
So they don't want you to call it science.
do you think we should modify the scientific method for that reason?
Well, so I think the scientific method is sound and works in that realm.
And
And that's the problem. You just have to realize where does this work? Another example, since we brought
in
it
that
up,
realm.
Newton's laws work great at slow velocities here on Earth where most of us live.
Mm.
It breaks down Newton's theories. See, this is one where you have to know where the model works, the theory. It works well for most people in normal situations. But when you start going near the speed of light or near a black hole, well, now you have to, Newton's laws break down. They're not accurate enough. You have to start employing the theory of relativity. That works. Theory of relativity works on the small scale too.
Explain to us
Or-
what the
or
theory of relativity is.
The
in a
slow
nutshell.
scale. It's just why use it? It's more complicated. Newton's is simpler and it works. So you choose the right model for the right application, but you got to know what their limitations are. And that's what I'm just getting at with this consciousness idea.
Okay.
Scientists are just going, we don't have a model that can understand that, represent it yet.
Mhm.
So we're not going to. That doesn't mean they're not trying to. So, okay, and back to you. If you want your other question, but I just thought I'd finish the
Yeah. The
What did
relativity
you
theory.
hear?
I've heard a lot that it's relative to you. Time is relative.
True.
Yeah, that's why like Buddhist monks when they meditate and they're in like deep meditation, time tends to move slower for them, and their brainwaves prove that. They're more calm versus like me and you. You know, we're in this plane. So I mean, yeah, I'm not like
Jittery.
I was
No.
before the meeting. I was like, you guys have to schedule a meeting for me at work. And have a podcast. So yeah, versus us. So there's like brainwaves and things like that. So I guess like time. I don't know about space, but definitely time is relative to the individual. That's what I've heard.
And what's it mean to be relative?
Like how you can relate to it, how you perceive it. Consciously, you're aware of it. Like someone could be rushing. Two different people perceive the same thing differently.
Okay. Yeah. The special theory of relativity deals with, so this is more sound. People don't pick this apart. Reference frames that are not accelerating.
Okay, can you say that in English?
Yeah, exactly. That's, you're somewhere where you're moving at a constant speed.
Right.
So right now we're in an inertial frame because we're not moving.
Okay.
Or in a car tooling down the highway at 70 miles an hour. Wait, this is Utah, 80 miles an hour. They're speeding at a constant speed. That's an inertial reference frame. It's one that's not accelerating. It's not changing its speed. And for those situations, another example. I said we're not moving right now.
Yeah.
Technically, we are.
Yeah, we are moving.
Pick your reference frame. In this room, we're at rest with respect to this room, relative to this room. But we're moving on the surface of the Earth, spinning around in reference to the, a fixed star, or going around the sun, and so it's all relative. Position doesn't mean anything. Oh, that person is over there, or 12 feet that way. You say that way. If you just say 12 feet, doesn't mean anything. From where? From
where you
respect
are.
to
Okay.
where? You need an origin point. From that corner, you're going 50 miles an hour. So what? 50 miles an hour west. Okay. You need it relative to something, or it doesn't mean anything. And so historically, scientists tried to find that they thought light is a wave, and just like sound waves need the air to travel. It needs some medium to travel through.
Sound waves need a medium to travel.
So when we're talking to each other,
There's gravity. Is
Eh,
that the medium?
for air?
Yeah.
No, I was just giving an analogy
Oh,
first
okay.
before I go off on something weirder.
Go. Just as weird
Oh.
as you can.
Waves, sound waves needs a medium to travel through, or they can't travel. In other words, there's no sound in space, or it can't travel in space because there's nothing in a vacuum to allow the energy of the wave to be transmitted from one place to another.
Okay.
So they thought light worked the same way because as they started describing it as a wave, to help understand it, they figured it needed something. So they were doing tests to try to figure this out, and they never discovered it. Historically, they thought it was they called it the ether.
Yes. Yeah, man, that's one thing I was gonna ask you about. I googled that.
Well, those that are interested, we can get back to it. Michelson and Morley, two scientists, did an experiment to prove the ether. They thought it existed. They thought this experiment would prove it, and they built an interferometer, a really sensitive thing to detect the changes, interference patterns in waves. And it was the most successful failed experiment probably in physics history.
This was in 1880, right? That I googled it,
Yeah.
1880, 1889. So it was over 100 years ago. Is what I'm trying to say.
Yeah. So they were trying to prove it to justify how light traveled,
Mm-hmm.
and they did it so well and so accurately, people believe and have redone it, that it proved there is no ether. There is no. So light is different. Light, this is what special theory relativity is based on, this postulate. So if what I'm getting ready to say, we ever prove is wrong, then the theory of relativity has to be rethought. And that light is the same speed for everybody in any reference frame, whether you're moving or not.
So it is or it's not.
The speed of light in free space, vacuum,
Yeah.
would be measured to be the same value for everybody, anybody looking at it.
Can you slow it down the way you're looking at it though?
Nope.
What about like you just calm down versus like someone that's tense?
No, the speed of light, no. Other things change. And this assumption leads to where you're getting to. And that was what the special relativity is based on. I just wanted to emphasize it so we knew where it started. Why this seems, people are going, yeah, so what? What we're used to is, let's say you're in a pickup truck, on a train,
Yeah.
and you throw a baseball, 50 miles an hour in one direction.
Mm-hmm.
Well, if you're standing on the side of the train as the train goes by,
Mm-hmm.
so the train's moving relative to you on the ground, I don't know. I don't want to get into math.
I get what
Throw
you're
some
saying.
numbers. Basically, if you throw the ball in the same direction the train's moving, the ball seems to be going faster relative to the ground. You standing outside, it's like the speed of the train plus the speed of the ball you threw.
Yes.
But if you throw it the opposite way of the train, it seems to subtract and it seems to be going slower relative to you outside the train. That's what we're used to. Light doesn't work that way. If you shine a light in the direction of the train or not in the direction of the train, the speed of the train doesn't add or subtract to the speed of light. You'll always measure it to be the exact same speed. So even if you're on a spaceship traveling the speed of light and you turn on a flashlight, in the spaceship, you still measure the speed of light coming out of your flashlight to be the same speed of light, even though your spaceship's going the speed of light.
Unless you hit a black hole.
Well, yeah, then it goes in and never comes out and you lose it.
Then we lost our audience too.
So you went with me with that part before I go on, but that's the weird part.
Okay. So let me ask you, did they actually discover ether?
No, they basically end up proving that it doesn't exist, and light does not need a medium to travel through. It can travel through empty space, and it's always traveling at that same speed, and everybody agrees on that. And so far, any experiment we've ever done has verified that.
And there's been multiple studies. You guys try to manipulate it.
Oh, yeah.
Yeah, shooting sound
Oh,
through it.
You know it because many people don't want to believe this of the consequences, so they work really hard to
What's
try
the consequences?
the special theory of relativity. Times can seem to slow down. You've heard time dilation or length contraction,
Yes, of course I have.
twin paradox,
But-
simultaneity. There's some weird consequences
yeah.
from it.
But Yeah, I guess time, but the way you perceive, you just slow down the way you perceive time, I guess. Right?
Well, just like, yeah, it can seem like, whoa, today went fast.
Yeah, that too. Or like no, like once I got hit by a car, T-boned, and for
Ooh.
that 5 seconds, I swear time slowed down.
I don't doubt that one bit.
I talked to the neuroscientist. He told me, he's all like, your brain goes into overdrive at that time because it's like fight or flight.
Yeah, I think there's some physiological things.
Yeah.
And with consciousness that we already established, we don't fully understand.
Yeah.
Special theory of relativity doesn't even touch on that aspect of it.
Okay.
They have no claim on that because, again, that's outside of the science.
Yeah.
claim.
How do you
But they can make some claims.
how do you put that in the laboratory and experiment? You really can't.
Not yet.
Not yet. I mean,
Yeah. But do we disbelieve people? Well, that many people can't be lying. There's something to it.
yeah.
But science, yeah, I think that's the best way to say it. Science can't put a claim on it yet because
Okay. Okay.
we don't have, we're not technologically advanced enough to go there.
Cool. Well, what's your thoughts on Elon Musk?
Uh,
On the last note.
I applaud him for all the cool things that he's did, and in a way, he's kind of non-conventional in that. Well,
Good. I
because
like
it's
that
like
too.
NASA's like, well, you have to do it this way,
No,
and he wanted to do it,
his own way.
and yeah, send a rocket into space. What do you mean? No, you got to go through NASA. That's what everybody thinks. But he's an out-of-the-box thinker, and I appreciate that, which allows us to branch out and move forward. It always causes some problems, but look at the things it's opened up too, and now that we're more aware of.
Yeah.
I mean, we got a Tesla orbiting out there, right?
Yeah.
I mean,
Oh yeah, the red
is
Tesla
that
car?
useful? I don't know, but is it cool?
Not, it's
Yeah,
hella
kinda.
cool. So for people that don't know what we're talking about, Elon Musk put a car, Tesla, on a rocket ship, and he flew it to outer space, and he just launched it out for fun because he can.
He had the money and the means. He was able to do it, and kind of like to show that he could. He did.
Yeah. Yeah, that's so when I started this podcast, it's like magic or science, certain things. I do want to like understand because I think sooner or later science can kind of explain everything. Eventually. Like consciousness.
That's the hope for scientists.
That's the hope. Well, there's a lot of stuff that we don't know.
I don't
but
know. I think there'll always be.
yeah, they'll be like, oh yeah, what's that
There's
like?
not an end in a way.
Like how are multiple verses connected? Oh yeah, and
Which
Doctor
is
Strange.
again why I got into this because there's always something we don't understand that we
Yeah.
can go investigate.
But when I talk to some scientists, they're like very closed off. Like no, like I don't, like that's not even possible. Like there's no way. Why do you think that is? Like why did they build some?
Because there are current theories and laws and
Mhm.
models that's given them say or predict that shouldn't be.
Until it's proven otherwise.
And so, yeah, based on what we know and what's comfortable,
Yeah.
it doesn't make sense. I mean, if you say, here, I'm going to take this ball and let go of it, and then say, oh, it's going to go up instead of down. Well, most people will laugh at you. That doesn't happen. They'll say, because the current laws and predictions and theories we know say this, and I can predict it and calculate it, and I'll tell you how fast it's going and how much energy and blah, blah, blah. And it's worked for us. And nobody's ever observed that. So it just seems weird. Like that would go counter to what we quote unquote know. But I find it unfortunate. And so good scientists should be skeptical. Shouldn't just believe any old thing.
I think everyone should be skeptical.
But should we be closed-minded not to investigate it or try to verify it? Well, look, I let go. It didn't happen, like you said. Well, they claim it did. Well, how'd you do it? Can we repeat it? And we should try it. But if it doesn't work after 1,000 tries,
Yeah.
we tend to give up on it and say, well, no, we're going back to what works. But if we are never open to it, we'll never learn something new.
That's true. Yeah, I like that concept. I like that a lot.
So I find it disheartening when scientists are too close-minded. But a lot of people, and I've got the emails too, they're typically called, for lack of a better word, what's a good word? I don't know. Historically, they were called crackpots. These people that
Yeah. Like
send you emails, they'll mass send out emails for theories they have.
yeah.
Like, well, this isn't the way it is. Well, I read probably more of those than most scientists do.
Yeah, because it's
I'm
fun.
like, and then and every time I'm reading it, yeah, I'm going off of what we already know. Well, that goes against what I've experienced and seen and justified and got evidence for. Thus, there's one knock against it. Well, and if there's too many knocks, well, then maybe there's too many holes in their plan.
Right.
But that's how people came up with it. Einstein was a patent clerk, right? Wrote these things, and people didn't want to believe what he said. And they didn't for many, many years.
Yeah, they didn't. What I love about Einstein, he said once, the more importantly than information is imagination.
Right.
Because if you imagine something, you can actually bring it into reality and create it. Information is everything that's happened.
And he's one of my mentors just because he
He
did
is?
a lot of thought experiments. Like, well, think about somebody in an elevator out in space and, dropping a ball, and this equivalence principle for those that are interested in gravity versus acceleration, and you can't distinguish. Goes back to his theories of relativity. But it was through thought processes that he started building these ideas. And then he got mathematic formalism to it, and people started thinking of ways that we could test it, and then they carry out the experiment, and what do you know, it worked, and here we are.
I've been to his former house. My dad's friend bought it actually in Pasadena.
What?
Yeah, it's on the hill. Yeah.
Your father bought...
No. My dad's friend.
Your dad's friend purchased one of Einstein's past houses. That's
Yeah,
cool.
his main house, because it's right by Caltech, and that's where he worked for a long time. California Institute of Technology in Pasadena. That's where I grew up,
Oh.
and he bought that house.
Cool.
Yeah, there's like a special thing, plaque. It's like, this house is Einstein's. It's actually pretty cool.
So I've been thinking with your podcast, magic or science?
Yeah.
It goes both ways. People like to go to see magic because they kind of like being, that awe factor.
Yeah.
Oh, I don't understand that. That's cool. And then their minds are immediately like, how'd that happen? How do you do it?
Yeah.
And half the audience are like, oh, there must be an explanation for that, which
Right.
there is with typical magical shows, but we don't know what it is. Or we can't even fathom yet how they came up with a technique to make that happen. But wow.
Yeah.
But then I do lots of demonstrations, and many of them, there's a science side, and I love it because it requires no technique from a magician's standpoint. There's no sleight of hand and deceiving or whatever. I just show them a demonstration, and it looks like magic because that's just the way the laws of nature work until they understand those laws, and then it's less. Well, some say that removes the awe and wonder about it, but
And that too. But then again, if you go to an indigenous tribe and do it, we'll see what they think of it. It's legitimately magic to them.
right. I like taking a rainbow. Some people, I'll start explaining the science behind it, only if they want to know. And they're like, you're ruining the beauty of the rainbow. But for me, it makes it even more beautiful, understanding how it works and that it's projected and we were able to see it. Knowledge is power. And
Knowledge is power.
the
but-
more I understand something, the cooler I think it is.
That's why I started this podcast, just so I could pick people's brains.
But we have to admit, we don't know everything, and there's some things we have to be okay with that,
That's awesome.
at
man.
least for now.
That's actually a great way for us to end the podcast. Do you have any last thoughts? Do you have any other information for people that are like just curious or skeptics?
Yeah, I often tell when I'm giving outreach presentations that there's one of the main differences, I think, between a scientist and a non-scientist is something happens, you see something, you learn something, you read something, you hear something, and you're like, what? Wow, how'd that work? Or, what's going on? Blah, blah, blah. A scientist will follow up on it, do more reading, ask questions, maybe do an experiment, try to find more out. That's
Start a
what scientists do. A non-scientist goes, oh, that was really cool. Wonder how that works. Oh well, and move on.
And that's, yeah.
And it takes both kinds. But
Yeah. Right on. Thank you, Professor. Appreciate it. I'm sure we'll meet again. Ladies and gentlemen, since you liked this episode, go ahead and subscribe, and we'll catch you next time.